Radiation hardened by design (RHBD) is a methodology that uses circuit techniques to make microcircuits more resilient to radiation as required at outer space in case of amateur radio satellites. In case of amateur radio satellites, it is more relevant for medium Earth orbit and geostationary satellites located at higher altitude. You may remember that Green Cube or IO-117 failed after a good period of operation, possibly due to radiation-induced damage. Ionizing radiation in outer space include particle radiation and high-energy electromagnetic radiation. On the terrestrial aspect, RHBD devices are needed around nuclear reactors, particle accelerators, and during nuclear accidents. Radiation hardening of semiconductor electronic components requires some design and manufacturing variations that reduce susceptibility to radiation damage. As the demand will be low and extensive development efforts are needed, production of radiation hardened chips lag behind the most recent developments. Of course, they will be more expensive than their off-the-shelf commercial counterparts. You would have read in the description of many amateur radio satellites that off-the-shelf components were used mostly by student teams. Though the production cost will be much lower, you can expect lower longevity of the amateur radio satellites produced in that way in the harsh radiation environment while in orbit. A single high-energy charged particle striking the circuit can knock thousands of electrons loose, causing electronic noise and signal spikes. In case of digital circuits, this can cause inaccurate or unintelligible outputs. For satellites, this can occur in the Van Allen radiation belts surrounding the Earth. Van Allen radiation belts extend from an altitude of about 640 to 58,000 km. Van Allen radiation belts contain electrons with energy levels up to 10 million electron volts and protons with energy levels up to hundreds of million electron volt trapped in the magnetic field of the Earth. Cosmic rays coming from all directions in outer space having energies ranging from 0.1 to 20 giga electron volts also contribute to radiation risk of satellites. Cosmic rays consist of protons which contribute about 85%, alpha particles, helium nuclei which contributes 14%, heavier ions of 1%, as well as X-rays and gamma rays.